a little more sense. So we talked about this in class a couple weeks ago, but the first fraction anyone ever learns is 1/2. And we learn that because once it's past our birthday, we're not just 4. We are not just 4 anymore. We're 4.5, and you better get that right. And so our blue fraction is 1/2. Get that back down to normal, since I'm not coloring. Our first fraction we learned was 1/2. And then someone just decided to say it was 2/4 and 3/6 and 4/8. And you were just supposed to get that. So what happens, let's see if I can make this work with what I want to do. I love digital teaching. All right. Then everybody decided to make everything crazy and say all of a sudden that there was 2/4. And you're like, how is that possible? And basically, what's happening is that you take your whole piece and cut it into 4 different pieces. And that means all of a sudden that same half is 2 out of the 4 pieces. And of course, we can't just stop at cutting them into 4 pieces. We can cut them into 6 pieces. And you're like, well, how does that happen? Well, if you split your pie into 6 pieces, all of a sudden that 1/2 is 3 out of those 6 pieces. And then we're not done because we could keep on going. So the logic is that the more pieces you have, the smaller the pieces are. So if we can think about this like a pizza, you and I are going to split this pizza. I get half, you get half. Great. But then all of a sudden 2 more people come and our pieces are smaller. And then 6 people come, and next thing you know, our pieces are smaller. We had to take that same half and cut them into 3 pieces. And that's what equivalent fractions mean. Because when you take 1/2 and cut the part you have into 2 pieces and the bottom part into 2 pieces, that's where you get 2/4. And if you take 1/2 and cut the part that you have into 3 pieces, and you have to cut the other part into 3 pieces, and that's how you get 3/6. And if you cut that part that you have into 4 pieces and the whole thing into 4 pieces, next thing you know, you've got 4/8. So the bigger the denominator, and that's the number on the bottom, the smaller the pieces. So I know some of y'all are just learning how to take notes from a video, but now that you watch that all happen, you're going to press pause and you're going to write all of this down. You're going to make your own reference sheet about basics of fractions right here. Now, we just talked about equivalent fractions. That's what we just figured out. A lot of different ways to say the same thing. And the basic rule is, with fractions, whatever you do to the top, you got to do to the bottom. No one can get left out. If we cut the part we had into two pieces, we cut the other part into two pieces. We cut the top part into two, the three, the bottom part into three. Everything happens that way. Now, going forward, the math world is going to expect you to remember the 1/2 is the same as 2/4. That 2/4 is the same as 3/6. That 3/6 is the same as 4/8. That 4/8 is the same as 5/10. They're all half. And this is true for everything. And this is where you are starting to catalog doubles and halves. That 7 doubled is 14, and half of 14 is 7. That 8 doubled is 16, and half of 16 is 8. That 9 doubled is 18, and half of 18 is 9. And truthfully, if you were in my 7th grade class last year, we played knowing halves and doubles all the way to 100. And that's something that you can practice. But math is going to expect you to recognize this relationship just by visually seeing it. Math is going to be able to expect you to find equivalent fractions. So if my number here is 20 on the bottom, they're going to expect you to know that if I multiply by 4 here, I'm going to get 20. But that means that I have to multiply by 4 here to get 16. That's imperative, that you can understand what's missing between multiplication and the answer. And that's why factor pairs are such an important thing. Because if you go to 20, you can see that this 5 and this 4 are part of the game. Let's get this. I'm going to put this in my document. In having that here allows me to be able to see, oh yeah, here's my factor pair. That's why I know 5 times 4 is 20. That's the basis of a lot of stuff that we're doing with proportions and ratios this year. Now, I don't know about y'all, but when I have taken 3/6 and I add 1/6, I'm rejoicing because these guys have the same denominator. That was like the Holy Grail. That 6 just tells me the size of every piece. And so if I go back up here to my lovely drawing, we'll bring this down here. And if I add another 6 here, that means I have 4 out of the 6 pieces ready to go. And then you get it wrong. And then you're like, what? Hey, what? Why? Why am I getting it wrong? Because that's not fair. And I agree with you. 4/6 is correct. But the wonderful world of fractions says your answer must be in simplest terms. So they're wondering, can you make your pieces bigger? Can we try something like that? So we're kind of like, okay, what do we do? I don't know what to do. So what I'm going to ask you to do is use factor pairs. And you're going to rewrite 4/6 using factor pairs. And what I mean is I'm going to go back here. I'm going to take a screenshot. And I'm going to take a screenshot of 4 and its factor pairs. I'll make this small. Okay, there's 4 in its factor pairs. And then I'm going to go back here and I'm going to take a picture of 6 and its factor pairs. So I'm going to go back to my pictures. I didn't get to it fast enough. And I'm going to crop this because I don't want all the factor pairs in the world. I just want 6. And now, there are my factor pairs for 6. And I'm looking for factors that match, that are bigger than 1. And if I look here, 2 is under both. For 4, the factor pair with 2 is 2 times 2. For 6, the factor pair with 2 is 3 times 2. So what I'm going to do is I'm going to take that information and rewrite 4 as 2 times 2, and then 3 times 2 on the bottom for 6. Now, one of my favorite parts of division is that I know that 2 divided by 2 is 1. Because these match, I can get rid of them and they cancel out. And so what happens is that instead of having 4 out of 6, I now have 2 out of 3. So I can take those 4 pieces and give each person 2. So if we look at our fraction, and I'm going to make thirds out of this, which is crazy when you think about it, right? Well, first off, I forgot the other part of this. So there's my pie. So instead, my pie is now in 3 pieces, and I have 2 of them. So that's what simplest terms means. It means we haven't cut any extra pieces. But this whole reducing thing feels overwhelming. How do you know? So let's say that I took 1/4 plus 2/4. And again, I'm doing the happy dance because my denominators are the same. My pieces are the same size. I can count them. And I'm like, okay, what do? I don't know. I literally don't know how to do this. I'm going to do my factor pairs. And thankfully, we just have 4 up here. So I can bring that all the way down here. And I've got 4 taken care of. And I'm going to crop it a little bit, and I'm going to take the top 4 out. And I'm going to have just these 2 factor pairs. And I can even erase my highlighting here. And so now I know those are my factor pairs for 4. Now 3 is a really easy one, because if you look at the factor pairs for 3, they've only got 1. 3 times 1. I don't even need to copy it. I can remember that and write that right here. I'm really good at copying one thing. I struggle when there's more than one thing. And this time, when I look at repeats, they both have a 1. The 2 doesn't have anything to do with the top. 3 doesn't have anything to do with the bottom. And when my factor pairs that I can work with only share a 1, I'm done. My answer is over. And 3/4 is simplified, and I won't get marked off because I didn't reduce it. Now, I can tell you that if you had done this CMAS problem and your answer was 4/6, they would have had 4/6, they would have had 2/3, they would have had 2/6, and they would have had 1/3. And you 100%, if you had chosen 4/6, you would have gotten it wrong. Because 2/3 is the simplest form. And it's definitely not a fun trick, but factor pairs can definitely help you. So now here you would press pause. I will pause it right here. See if we can get this back down here again. Maybe over here. And you're going to pause and take and copy these notes. And then you're going to scroll it up and pause and take copy of these notes. This is what you're working towards. So now that you've gotten these all done, I want you to see if you can reduce these fractions using your factor pair sheet. Press pause and try these on your own. So if you're stuck on the first one, I'm going to tell you to write what are your factor pairs for 6. I know obviously it's 6 times 1, but I also know it's 2 times 3. 8 is 8 times 1, but I also know it's 2 times 4. Your job now is to circle the ones that have matching factors greater than 1. So that means I'm getting rid of this guy and I'm getting rid of this guy. And sure enough, these guys have a match. And the matchy-matchies cancel. And whatever's left is our answer. The matchy-matchies are like your best friend in the world. If I look at 12, I'm actually going to look at 14 first. And I know 14 is 2 times 7. Because 14 is 2 times 7, I'm immediately drawn to the fact that 12 is 2 times 6. These cancel because they matchy-matchy. And there is my reduced form. Man, I would never have guessed 6/7 without factor pairs. Never have happened. Now here, 8 is only 4 times 2. But if I look at 18, 18 only has a 2. It doesn't have a 4. So I'm going to choose the 9 times 2. And the matchy-matchy cancel. And whatever's left is my answer. I will post a practice worksheet with this recording in Google Classroom. Thanks for getting comfortable with fractions with me.